So in this video, we are going to continue the problems on the curved beams. So let us consider a problem, determine the maximum tensile stress and maximum shear stress of the component as shown in the figure, and indicate the location of the maximum stress. So construct the boundary free body diagram with the central line of curvature, force, CA and NA and all other remaining values. So first one will be the inner radius R is equals to 100 mm, outer radius R naught is equals to 150 mm, radius of centered axis, so RC is equals to RA plus 50 by 2, I am going to get as 125 mm. And the cross section is given as circular, so I am going to take the radius of neutral axis as Rn is equals to root of R naught plus root of Ri whole square divided by 4, so I am going to get as 123.737 mm. So E value I am going to find out Rc minus Rn, Ci I am going to find out Rn minus Ri, C naught will be R naught minus Rn, and area will be pi by 4 d square, and length will be, if I go for the length, that is L value, the distance between the centered axis to the force, so from here it will be Rc plus 125, so that value I am going to consider for L. So once L value is known, I go for bending stress, that is Mb is equals to F into L, so I am going to get Mb is equals to 25 into 10 to the power of 4 Newton mm. So direct stress I will go for, so direct stress will be sigma d is equals to F by A, so force is given, area is known, I am going to get a value as 0.5093. So bending stress at the inner fiber, sigma Bi is equals to MBCI divided by AE into Ri, so I am going to get 23.9294, that is a tensile stress, so it will be a positive one. So the bending stress at the outer fiber will be compressive one, so I am going to have to take the negative sign. So while substituting all the values, I am going to get that one as minus 17.6506. The combined stresses at the inner fiber, that is sigma Ri is equals to sigma D plus sigma Bi, so I am going to get as 24.4387, so that is a tensile stress. The combined stress at the outer fiber, sigma R naught is equals to sigma D plus sigma B naught, so I am going to get as compressive, that is minus 17.1413. So the maximum tensile stress will be 24.4387, and the maximum shear stress tau max equals to 0.5 into tau sigma max, that is 24.4387. I am going to get as 12.2193 at point B. So I can see the stress diagram. So cross section, then the direct stresses, the bending stress and the combined stresses. So draw the curve as a hyperbolic curve, not as a straight line. Let us go to the next problem. An open S-link is made up of 25 mm diameter rod as shown in the figure. Determine the maximum tensile and compressive stress at two particular points, that is R and S, P and Q. So let us consider the first one, R and S. So I want to take that values. So I want to draw the free body diagram. So consider in the cross section PQ. So I am going to draw the cross section PQ. The PQ cross section has been drawn with R I and RC is equals to 100. So I am going to find out again inner radius, outer radius, radius of neutral axis Rn, the distance of a neutral axis from the centered axis E is equals to RC minus Rn, distance between the neutral axis to the outer fiber, so inner fiber Ci is equals to Rn minus Ri, neutral axis to the outer fiber R naught minus Rn, area of cross section pi by 4 into d square, distance from the centered axis L, that will be equals to RC in this case, so it will be equals to 100. The bending moment formula, that is Mb is equals to F into L, the force is given and length we are going to find out, so I am going to get as 1 lakh Newton per mm. So combined stresses at the outer fiber, so direct stress plus the bending stress I have to consider. So direct stress is F by A, and the bending stress directly I am going to write as Mb C naught A into R naught. I am going to substitute the values. So when you go for outer fiber, so I am going to get as minus 56.36 Newton per mm square. So it will be a compressive stress. So combined stress of the inner fiber will be direct stress plus bending stresses. So F by A, since it is inner, so I am going to get as Mb into Ci divided by Ae into Ri. Substituting all the values, I am going to get as 72.466 Newton per mm square, that is as tensile. So coming on to the next cross section, that is RS. So I want to construct the free body diagram. So I want to find the RC value, that is 75, RA value 62.5, R naught 87.5, area I am going to get as 490.87, Rn will be 74.4755. So as E value are going to get as 0.5245. Ci we are going to get as 11.97. C0 we will be getting as 13.02. So L equals to Rc equals to 75 mm. So MB F into L 1000 into 75, 75,000 Newton mm. So combined stresses of the outer fiber will be going for a compressive. So F by A minus MB C0 divided by AE R0. So substituting the values I am going to get as minus 41.324 Newton per mm square. And combined stresses of the inner fiber, so I am going to get as direct stress, that is F by A plus MB Ci divided by AE Ri. So plus I am going to indicate that it is a tensile. I am going to get as 55.816 Newton per mm square. So the maximum tensile stress will be 72.466 at point P. The maximum compressive stress will be 56.36 Newton per mm square at point Q. And the maximum shear stress comparing to both the conditions I am going to get as 0.5 to sigma max, that is 72.466. So I am going to get as 36.233.